morning, Kelsey. Today we're going to be learning a new topic that deals with fractions. Before we dive into the new material, let's review a little bit.
Okay.
Now, we know that a fraction represents a part of a whole. Basically, what this means is a fraction describes how many parts of a certain size of something there is. Does that make sense? Since you know what a fraction is, can you give me an example of a fraction of an object? Let's use a cake as our example and pretend that I cut the cake into 8 different slices. Give me a statement that explains how much of a fraction of that cake you ate.
Well, I ate 2 pieces of cake, so therefore I ate 2/8 of the cake.
Awesome. Now, let's dive into the lesson of the day, equivalent fractions. As we already know, you are very familiar with what a fraction is and how to apply them to everyday situations. What we are going to learn about today is the subject of equivalent fractions. What do you think this means if you had to guess?
Well, equivalent means equal, so maybe it means fractions that are equal?
You're exactly right. We're going to talk about how to recognize when 2 different fractions actually equal each other. I know this sounds strange because when dealing with whole numbers, it's impossible for them to be equal to each other. For example, 6 doesn't equal 8, right?
Definitely not. That wouldn't make sense at all.
It sure doesn't. Let's think back to the cake example we just discussed a moment ago. What if I told you that when you ate 2/8 of that cake, you also ate 1/4 of it? What would you say?
I would say that sounds really strange. I mean, how can that happen? Can you explain that more?
That's exactly what we're here to discuss today. By using some examples, I'm going to explain this to you as best as possible. I've got some examples here with me. Okay. As you see here, this is a picture of a circle. Let's pretend like this is the cake we just talked about, and you said that you ate 2/8 of this cake. Can you shade in 2 out of the 8 slices for me?
Mm-hmm.
It's still recording. It's blank.
Yep, it is. Give me a shot.
When you're done, just hold it up so I can see.
Miss Horn, is this right?
That's perfect. 2/8 of that circle is shaded.
Yay!
Now, here's another picture of the same cake, except for this cake is divided into 4 pieces. I ate 1 of the pieces, so that means I ate 1/4 of the cake. Can you shade 1/4 of this cake for me?
1/4. I got a cake size. Here you go, Miss Horn.
Awesome. 1/4 of that cake is shaded. Now what I want you to do is lay both of those cards you just shaded on top of each other. What do you notice and what conclusion can you draw from what you see?
Well, there's an equal amount of space shaded in on both cakes. This must mean that 1/4 equals 2/8 because it's equal.
Exactly. I'm so glad that you are already able to see that. Does this make sense to you? Please tell me if you are confused.
No, this was easy and interesting. I feel confident in my answer.
Good. Please let me know if these other examples seem hard to you as we move on. For our second example, here we have a long and skinny rectangle that is divided into 6 equal parts. Let's pretend like this rectangle is a river, and that 4/6 of this river is filled with rocks. Please shade in 4/6 of the river.
Okay. Four. Here you go, Miss Horn. 4/6.
Very good. Fantastic. Now, here is the same river, except that it is divided into 3 parts. 2/3 of this river is filled with rocks. Please show me what it would look like by shading it in.
2/3. 2/3.
Very good. Now, let's do what we did in the last example. Please place one of the rectangles on top of each other and tell me what you notice.
They're the same again. Both sides equal each other.
Very good. I'm so glad that you're catching on to this concept. Let's try one more. Here is a square divided diagonally into 2 parts. What would you like to pretend the square is? Use your imagination.
Let's make it a shoebox, because I love shoes.
Perfect. That will actually work perfectly with this example. Let's say that one of the shoes in this box takes 1/2 of the box. Please shade in 1/2 of the box.
This one.
Very good. Now, here's the same shoebox, except for this one is divided into 4s. I'm going to ask you to shade in 2 out of the 4 angles of the shoebox. I'm sure by now you're familiar with what to do next, so when you're done, please place one over the other and tell me what you see.
They're equal.
Very good. Both of these shoe boxes have the same amount shaded. Therefore, they are equivalent fractions. You have really impressed me with how well you have grasped this concept. Do you have any more questions for me about anything over this topic before we move on?
This is really making a lot of sense to me. I don't have any questions at this point.
Okay. Let me know if you do. We're going to move on to the fun part.
Yay.
Please have these back. Now we're going to test your skills and put what you have learned into action. I have a group of flashcards here. I'm going to hand you one of them and you will tell me what fraction is already shaded in. In our activity, you had actually shaded them in yourselves, but I already have them shaded, and I just want you to tell me what the fraction is of the shade. Does that make sense?
Mm-hmm.
I will continue to show you more flashcards, and you will answer them in the same manner as you did the first one. There are 10 flashcards total, but here's the trick. Each flashcard has a match. They will be listed as different fractions, but each of those fractions has an equivalent match hidden there somewhere. Once we have gone through all 10 cards, I will lay them all out for you and you will have to match them to their equivalent match. Do you have any questions?
Is this timed, or do I take my time?
I'm glad you asked that. This is not timed. It's a fun game, but the goal is to get you to understand what equivalent fractions are and how to pair them.
That's all. Well, let's play.
Okay, I'm going to just show them to you. Don't worry about matching them at this point. I'm just going to show them to you and you just read to me what the fraction is.
Okay. 1/2.
And what's the shape?
A circle. A circle and 2/4. A square and 4/8.
Good job.
A square and 1/2. A triangle and one. It's a hole.
The whole thing is
Yeah.
shaded in. Very good.
A triangle and a hole. They're the same thing.
Those were the same thing. Maybe that will apply later.
Okay. A rectangle and 2/3.
Very good.
A rectangle and 4/6. Rectangle, square, and 2/6.
2/6. Good. It's more of a. It's technically a rectangle, but you can call it a square.
Okay. A rectangle and it's 1/3.
Very good. That was all 10. Now what I'm going to do is lay these down on the floor, and you can match them for me, and I won't put them in order. Okay?
Okay.
If you want to stand over here, and I'll do it for you.
Okay. Well, since one rule and one rule triangles, I think those match.
Very good.
And let's see here. 2/4 and 1/2 match.
Very good.
And 1/3 and 2/6 match.
Very good.
And 1/2 and 4/8 match.
Good job. We haven't even discussed that one yet.
And 2/3 and 4/6 match.
Was this an easy task for you to complete?
Yes, because it's easy to match the shapes and the shadings.
Very good. You may have a seat. You did an excellent job in this activity, Kelsey. I'm really proud of how well you grasped this concept. Thank you for being so cooperative and staying engaged the entire lesson.
Thank
Now
you,
it's-
Miss Warren.
You're welcome. Now it's time to review. We covered a good amount of information in this lesson, and it is only the beginning. Later on in the school year, we're going to dive deeper into the study of equivalent fractions and how to convert them mathematically, and not just seeing the equivalence of the shaded areas. You did very well at staying focused and keeping up with the activity, even though it was taught and put into practice in a very short amount of time. Just to review, remember that equivalent fractions are two different fractions that numerically look different but technically equal each other. Off the top of your head, can you remember two fractions we discussed tonight that are equal?
Well, the rocks in the river, that is 4/6 and 2/3.
Very good. I'm so glad to see that you can already remember some of the equivalent fractions by memory. I can tell that in the future this is going to be an easy concept for you to understand once we get into the more difficult side of using equivalent fractions. This is awesome because this is a topic that will be beneficial to you in your adult years in your everyday life. We can refer back to our example from the very beginning with the cake. Next time you actually have two pieces of the cake, you can tell them that you actually had how much of it?
2/8.
Which would also be
1/4.
very good. That's all I have for you today.
Thank you, Miss Warren.
Very good.